All right, so we are going to talk about the solutions in this video. So make sure that you've actually tried all these problems, and you're going to need to pause often here to keep track, take notes, and do the problems many times on your own until it clicks. So let's look at the mini genie. So here, what Allie does is she identifies which stone contains the jewel with no problem. First, remember that she's given 9 stones. So let's draw a picture. 1, 2, 3, 4, 5, 6, 7, 8, 9 stones. She arranges the stones into 3 groups of 3 and places one group on one side of the first balance scale. So we've got a balance scale here. Wow, you can see I'm not the best drawer. And so we're just going to take this group here, and we're going to take these 3 and put them there. And we'll take these 3 and put them there. Now what happens here? If both sides weigh the same, then we know that the heavier jewel must be in there. So then we knock it down to 3. Now if they weigh differently, then we know which one is heavier. Which set is heavier. So let's say this one weighs a little bit more, then we would take this 3. If this one weighs more, we would take this 3. If they weigh the same, we would take this 3. But no matter what, we're going to walk away from that balance with 3 instead of 9. So now we'll just do it again. Let's say we've got another scale here, and she is going to place ones on each side here. Now what happens? If they weigh the same, then we know that's the winner. That's the one. If they weigh differently, then we know that one of these is the one. So whichever one, she'll be able to figure out which one weighs the most. And so that's how you can solve this problem. Let's take a look at the fountain of knowledge. All right, so suppose we fill up the 10-ounce glass with mango juice. All right, so now we've got this 10-ounce glass, and we fill it up with mango juice. So there's 10 ounces in there. And we're going to slowly pour it into the 6-ounce, and we're going to stop as soon as that glass is full. So when I pour this in, I end up with the 6-ounce becoming full, right? That one's full. And in my 10-ounce cup, how much is left? Well, I had 10, I got rid of 6, so there's 4 ounces left in my 10-ounce cup. So now we're going to actually we're going to dump the 6-ounce cup. So we're just going to dump that out back into that big pool with the rest. And so now we've got an empty 6-ounce cup, and we've got 4 ounces in our 10-ounce cup. And we're going to refill it with the 4 ounces from the other glass. So we're going to take those 4 ounces and we're going to pour those into this 6-ounce cup. So now what happens is the 6-ounce cup is going to have 4 ounces filled. The 10-ounce cup is empty now. And how much is left in this 6-ounce cup? Well, there's 2 ounces that are empty. So now if we refill the 10-ounce glass from the pool, we can again slowly pour the contents in. So now we're going to fill this up. So let's fill up this 10-ounce cup. So we've got our 6-ounce cup has 4 ounces, 2 ounces left over, and our 10-ounce cup is full. Now, we'll slowly pour the contents of this into this. Now, if I take these 10 ounces and I pour them in, I'm going to get rid of 2 more ounces here. So what's going to be left in my 10 ounce? It's going to be exactly 8 ounces, which is the goal. So go ahead and play that as many times as you need to. It's also the book has a good picture as well. But give that a try on your own. And that is one method here. Now, there is actually another method, and see if you can figure that one out. All right, so now we're looking at the dodgeball game here. The idea is that Player 1 wins if their row matches any row to player 2, and player 2 wins if there is no match. So we want to be player 2 because we're in a better position. So let's play it out. So player 1 fills the first row. Let's say they fill it. It really doesn't matter. But as player 2, I'm going to look at this first row. And if the first letter is an X, I'm going to write an O. I don't want it to match. And I don't care about the rest of them. So the player, if it's an O, we write an X. Notice that no matter what happens later after this point, we're certain that the row we will create will definitely not be the same. This row is not going to match row 1. So we know we're safe there. The two rows will differ in at least the first box. So player 1 now writes down the second row. So let's say, oh, okay, you want to play that way. I'm going to go like that. And then you just say, okay, if we're going to examine the second letter in this row. So they did an X there. So I'm going to do an O. And now I know it doesn't match the first row because the first row started with an O. And I know it doesn't match the second row because the second number doesn't match. And we could keep going. So if they did, let's say they thought they were being clever this way, I'm going to look here and I'm going to make that an O. And so far, nothing is matching. And if I keep going that, no matter if I continue through, that player 1 will never have a row that matches player 2. And so I do want to be player 2. Now, if they are, so looking here, if we pose the question, suppose that we are player 1 and our opponent is doing this, and makes a mistake by placing the wrong letter in the first box, can you now describe a strategy for player 1 to win? See if you can give it a try. So for story 7, let's make a deal. We're going to run through this a couple different ways because this one can actually be a little bit challenging. So I'm going to explain it one way, then we'll look at the textbook, and then we'll look at an experiment. So we've got 3 doors to choose from. We've got door number 1, we've got door number 2, and we've got door number 3. When we first start this, our first choice that we pick, we're taking a guess out of 3. So if we're right, then it's a chance of 1 out of 3. And if we're wrong, there's 2 out of 3 doors that could be wrong, right? There's only 1 Cadillac and then there's 2 mules. So our very first choice, there's a chance that we're 1 out of 3 correct. So let's just say, so this door is worth 1 out of 3, this door is worth 1 out of 3, and this door is worth 1 out of 3. So let's say we choose this first door. Now Monty goes ahead and he chooses one of the mules that he knows, doesn't have the right answer. So he shows you this door here and he takes this one off the table. So remember that 2/3 here is left. So we say, all right, I choose here. If I was to stick with my original choice is worth 1/3. Doesn't matter what happens. I chose that out of 1 out of 3. But if I stay, the probability doesn't change. That choice is still 1 out of 3. But if I were to switch, what I'm saying is that this section here, all of these the chances were 2/3. And so if I switch, it is a probability of 2/3 being right. So that can be a little bit confusing, that the idea is that you do want to switch. So let's take a look at the textbook here. The textbook does a really good job of explaining it, and I would encourage you to read it through. But what I think makes the most sense here is if you actually take a moment and do a little experiment. So grab a friend and 3 cards. You can use an ace and 2 4s or anything else that would be the mules. And go ahead and run this experiment. So the dealer peeks and knows where the Cadillac is, knows where the ace is. So as a guesser, you're going to pick the card. And remember, you're picking, you have a 1 out of 3 chance. And the dealer's going to reveal a mule card. And you will decide whether you switch or not switch, and then they'll reveal the answer, and then you calculate it. So you're going to play the game 30 times and never switch. Each time you stick with your original 1/3 chance of being right. And then calculate, see the probability, how many times you were right by doing the number of times you were right divided by 30. And then if you do it, that 30 comes from this number here. Then the second time I want you to switch every time. No matter what they're going to do the mule, you're always going to switch. See how many times you were right, divide by 30. You're going to see that it's going to be about 1/3 and about 2/3. Why? Because when you first start, you have a 1/3 probability of being right, which means the other doors left are 2/3, so you want to switch. Run through that experiment, see what happens, and that concludes these here. And so lessons for life here, you know, we can learn a lot in math. All of these lessons come up while we try to solve difficult problems in real life and in the math classroom. And so that concludes this section.